Hello, Accelerated Chemistry students. This is Ms. Crisafoli, and this is your Chapter 16, Section 2 video notes all over concentrations of solutions. So the first concentration of solution that we're going to talk about or calculation is molarity. So the concentration of a solution is a measure of the amount of solute that is dissolved in a given quantity of solvent. A solution that contains a relatively small amount of solute is a dilute solution, and the concentrated solution contains large amounts of solute. So in chemistry, the most important unit of concentration is molarity. Molarity has a unit of capital M. It is the number of moles of solute dissolved in 1 liter of solution. Molarity is also known as molar concentration. So when we are making solutions for labs, we follow a very specific set of procedures that allows for us to make the specific solution we're looking for. So this video is going to explain how to make a 1 molar sodium chloride solution.
So we have to make a 1 molar NaCl solution. Now 1 molar means we're going to put 1 mole of NaCl in 1 liter of solution. And if we do the math, 1 mole is 58.5 grams. You add up the mass of 1 mole of sodium plus 1 mole of chlorine, put them together, and get 58.5 grams. Then you fill the flask about halfway with water. This is a 1 liter flask, 1,000 milliliters. Fill it up about halfway, just enough water to get all of the salt dissolved. Now add your 1 mole. If we were making a 2 molar solution, we'd add 2 moles, but here we're just adding 1 mole. Swirl it, try to get it all dissolved. You may have to heat it, but we're pretty good here. And then you're going to add some more water. Now you have to be careful here because you don't want to exceed the 1 liter mark. So you keep adding water quickly until you get close to that 1 liter mark, but you don't want to exceed it. So stop before you reach that point. And then use a squirt bottle or a pipette or a small graduated cylinder and just add a little bit of water at a time. And then as soon as you hit that line, you're done. You now have 1 liter of a 1 molar salt solution.
So that is the procedure that I follow when I make all of our solutions in lab. So now let's talk about how we calculate it. So to calculate the molarity of a solution, you're going to divide the number of moles of solute by the volume of the solution in liters. So your equation is going to be moles of solute over liters of solution. So as always, let's do a practice problem. So 1 saline solution contains 0.9 grams of sodium chloride and exactly 100 milliliters of water. And I want to know what the molarity is. Anytime you think molarity, you should think moles per liter. So we have to convert our grams per 100 milliliters to moles per liter. So this is how we're going to do it. We're going to go grams per 100 milliliters to moles per 100 milliliters to moles per liter. So what are our knowns? And what are our unknowns? We don't know what the concentration is in molarity, in moles per liter. So first we're going to set everything up. So our solution is going to have an original concentration of 0.9 grams per 100 milliliters. We are going to use 1 mole of sodium chloride, has a molar mass of 58.5 grams of sodium chloride. And then we know that there's 1,000 milliliters in 1 liter. We make sure everything cancels. And we're left with moles per liter, which is what we want. And so when we do our math, we end up with 0.15 moles per liter. Or when we write it, and what I want you guys to get used to writing is 0.15 big M, which means molarity. So we always check our answers to make sure they make sense. So the answer should be less than 1 molar because we don't have a 1-to-1 ratio of solute to solvent. And so we also know that 9 grams is less than 1 mole of sodium chloride. So it should be less than 1 molar. And we have to make sure that our answer is always rounded to the correct significant figures because I'm very picky about that. So now let's calculate the moles of solute in a solution. So when you have laundry detergent bleach, it is a dilute solution of sodium hypochlorite, which is the main ingredient in bleach. So how many moles of solute are present in 1.5 liters of a 0.70 molar NaClO solution or sodium hypochlorite? So again, we're going to set this up as a conversion. You can see that a lot of the problems that we have solved over the year are just conversion problems. So we know what our knowns are. We have a volume of 1.5 liters and the molarity is 0.7, and we don't know how many moles that is. So what we're going to do is we're going to set this up. So we're going to multiply our volume by the 0.7 moles over 1 liter. Make sure that we understand that 0.7 moles per 1 liter is big M. And when we do that math, we need 2 sig figs at the end, so that's 1.1. We have to make sure that it makes sense, and the answer should be greater than 1 mole but less than 1.5 because the solution is 0.75. And as always, sig figs are important for us. So now let's talk about making dilutions. So both of these solutions contain the same amount of solute. You can tell by the color of solution A that it is more concentrated than solution B. Solution A has a greater molarity then. The more dilute solution B was made from solution A by adding more solvent, in this case water. So the diluting a solution reduces the number of moles of solute per unit of volume, but the total number of moles of solute in the solution does not change. So moles of solute before dilution is going to equal moles of solute after dilution. So when we're looking at diluting solutions, we are going to know that the definition of molarity can be rearranged to solve for moles of solute. So moles of solute is going to be our molarity times our volume. And so when we look at the total number of moles of solute remaining unchanged upon dilution, we know that the mole amounts are going to be equal. So the molarity times our initial volume is going to be the second molarity of the diluted solution times the new volume. And those two values are equal. So now this video is going to show you how to prepare a diluted solution from a stock solution.
Hi, I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today I'll be taking you through the appropriate procedure and technique for diluting a solution. A common laboratory technique is preparing a more dilute solution from a concentrated stock solution. In this case, we are going to prepare a 0.250 liter solution of 0.01 molar. We know our stock solution has a concentration of 0.250 molar. The first thing we need to do is determine the exact number of moles in our dilute solution. We know our concentration needs to be 0.01 molar or 0.01 moles per liter. Since we know our number of moles per liter and we know the volume we need, we can calculate that we need exactly 0.0025 moles of sodium chloride. Knowing our stock solution contains 0.25 moles per liter, we can take the number of moles needed in our dilute solution and divide by the concentration of our stock solution to calculate the exact number of milliliters that must be transferred into our new solution. In this case, 0.01 liters of sodium chloride solution, or 10 milliliters. This is the stock solution of sodium chloride that we will be diluting. Make sure to pour the stock solution into another container before inserting the pipette into the solution. This is because you do not want to contaminate your stock solution. In this case, I'm using an Erlenmeyer flask. Notice that I have clearly labeled the flasks to adhere to proper laboratory safety protocol. To prepare our dilute solution, we will take a 10 milliliter aliquot of our stock solution using a 10 milliliter volumetric pipette. To use the pipette, place the pipette in the liquid to be collected. Squeeze the pipette bulb and allow the liquid to rise up the pipette. You should allow the liquid to pass the line marked on the pipette, but before the bulb. Remove the bulb and place your other thumb over the end, creating a seal, and slowly release just the corner of your thumb, allowing the liquid to exit so that the meniscus is directly on the line marked on the pipette. This takes some practice, and you may need to use the bulb to pull more liquid into the pipette again. Never pipette by mouth. Once you have the exact amount of liquid required in the pipette, hold your thumb firmly over the end and transfer the pipette to a new volumetric flask. In this case, a clean 250 milliliter volumetric flask. Allow all of the liquid to flow out of the pipette. Do not use the bulb to force the liquid out, as pipettes are designed to deliver the exact amount of liquid, and there may be a small amount of liquid remaining at the end. Remove the pipette and follow the same procedure as before, filling the volumetric flask with solvent, Again, monitoring the meniscus until the exact volume is reached. You've now learned how to prepare a dilute solution from a stock solution. To see how to prepare a stock solution,
now, so let's do some calculations. So preparing a dilute solution. So how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of a 0.4 molar magnesium sulfate solution? So we are going to have to make sure that we know that there needs to be equal volume. So M1V1 equals M2V2. And we're going to solve for how much of the initial solution we need to take out and then fill the rest of that volume with water. So we know that we have a 2 molar solution to start off with. We want a 0.4 molar solution, and we want 100 milliliters of the 0.4 molar solution. We don't know how much of the initial solution we need though. So what we're going to do is we're going to rearrange our M1V1 equals M2V2 equation, solve for V1. We know we need a 0.4 molar solution of 100, that is 100 milliliters from a 2 molar solution. So that means that we need to take 20 milliliters of the 2 molar solution, and then we need to add enough water to increase the volume to 100. So that means that we will need to add 80 milliliters of water to make our volume total 100. Now, does it make sense? We know that the initial concentration is 5 times larger than the dilute concentration, and because the number of moles does not change in the initial volume of the solution, should be 1/5 the final volume of the dilute solution. Now let's talk about percent solutions. Percent by volume of a solution is the ratio of volume of solute to the volume of the solution. So isopropyl alcohol is sold in the bottles that you get from the drugstore or the grocery store, 91% solution by volume. So that means that you have 91 milliliters of pure isopropyl alcohol and 9 milliliters of water. And we can calculate this by taking the volume of our solute over the volume of our solvent times 100. And the concentration that we know is going to be written as 91% volume per volume, which means volume of solute per volume of solvent. So now let's calculate the percent by volume of an ethanol solution. We have a final solution that is 85 milliliters of ethanol, and it's going to be diluted to 250 milliliters of water. So how do we calculate that? We know that we have that 85 milliliters and that 250 milliliters. So we're going to take the ratio of those two, make sure your solute's on top, and then the solution is on the bottom. So when we do that, we put 85 milliliters on top, 250 milliliters on the bottom. Make sure it's a percentage. So we need to multiply that answer by 100, and we'll get 34% ethanol volume for volume. And then does it make sense? We know the volume of the solute is about 1/3 the volume of the solution, so that answer is reasonable. And then always, I'm a stickler for sig figs. The last way we could talk about solution percent or percents of solution or solution concentrations is looking at mass percent. Mass percent is more suitable when your solute is a solid as opposed to when your solute is a liquid. So the percent by mass of solution is the ratio of the mass of the solute over the mass of the solution. So we want to know how many grams of glucose are needed to make a 2,000 grams of a 2% glucose solution. So how are we going to do this? We're going to need to convert the mass of the solution to mass of solute, and we know that it has to be a 2% solution. And so we know that we have a mass of 2,000 grams for our solution. We know that the percent is 2.8. And so we need to know how many grams of the glucose we're going to need. When we do this, we're going to use this as a conversion factor. So 2.8 grams per 100 grams of solution. So when we do that, we know that we have a 2,000 gram solution. We know that our conversion is that we need 2.8 grams per 100 grams of solution. So we would need to dissolve 56 grams of glucose into 2,000 grams of solution, or in this case, water, to make that solution 2.8% by mass. And again, does it make sense? So we know that 20 times 100 grams, that's how we're going to prepare the mass of the solution. So since a 100 gram sample is about 2.8 grams. We can do 20 times 2.8, which is 56, and that's about what we got. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition textbooks, resources, CD, and pearsonchem.com. Thank you so much. Have a good night.